So, for probability lecture 6.2, we're going to get a little more into probability, and the first thing we're going to talk about is a sample space. And it says a sample space with the abbreviation of S, that's a capital S, of a random phenomena is the set of all possible outcomes. Okay, so I have an example here. Coin flipping for 2 coins. So here are the possible outcomes for coin flipping. So for coin flipping, we could have tails, 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 tails. Or the first coin could be tails, and the second coin could be heads. Or the first coin could be heads, and the second coin could be tails. Or the first coin could be heads, and the second coin could be heads. And all of this here, I'll put brackets around it because it's a set, is a sample space S. Because that's a set of all possible outcomes for the simple phenomena. So that's what sample space is. It's not for. Sample space in this case is TT, TH, HT, and HH. That's a sample set. That's a set of all possible outcomes. Okay. So an event. An event is any outcome or a set of outcomes of a random phenomena. That is, an event is a subset of the sample space. So let's go back to flipping 2 coins, and we'll use this because it's so easy that it's something we can understand easily. So we know this sample space looks something like this, right? Because we just did it. Okay. And the event might be getting a tails. So if our event is getting a tails, flip a tails, then the subset would be tails, 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 heads, or heads, tails. And if you're confused if heads, tails, and tails, heads are different, they are, because it's the first flip of the coin is tails, the second set is heads, or first coin is heads and the second set is tails. If you're still not convinced, imagine instead of flipping 1 coin twice, flipping, say, a penny and a quarter. So maybe for this one, the quarter's tails, and this one maybe the quarter's heads. So that might help you understand a little bit better that these are 2 distinct outcomes. But anyway, this is the event that we flip tails. It's tails, 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 heads, and heads, tails. Okay. So what is a probability model? It's a mathematical description of a random phenomena consisting of 2 parts, the sample space and a way of assigning probability to the events. So one of the things we could do is we could say, coin flipping's easy, right? Each one has an equal probability, but that's not always necessarily the case. So we'll take a look at this a little bit more in more detail later on. A tree diagram. Now I know it doesn't seem like this could actually be useful, but it is. It says you have a 6-sided dice and a coin. Using a tree diagram, what is the probability of having heads on the coin and a 5 on the dice? So here's what we're going to do. We're going to use a coin first. So our coin has 2 outcomes, right? For a coin, it's either going to be heads or tails. And then from this, we're going to make tree branches. Since this is a coin, we're probably going to need 6 outcomes. That's not working out too well for me, is it? Let me try that again and see if we can get this a little bit better. I'll just do one of them and we'll... So let's start off this way. So the probability of getting heads is 0.5. The probability of getting tails is 0.5. You'll notice that these 2 0.5s add up to 1. So now let's try this again. Off of heads, we have 6 possible outcomes. 1, 2, 3, 4, 5, 6. That still didn't work out too good. And we'll number them. And the probability for each one of these is 1 over 6. and so on. So you can, and we have to do the same thing for tails, but because I'm having difficulty drawing it, let's just assume we did it. If you'll notice all these branches, they add up to 1. And all these branches, they'll add up to 1. And the way you calculate probability is, it's 0.5. For 5 is 1/6, so it's 0.5 times 1/6 is 1/12. Hey, if you remind me, I'll do another example in class on the board. Maybe that's a little bit easier to see, but that's the essence of a tree diagram. The next thing we're going to go over are the rules for probability. So probability rule 1, you're going to want to write this down. It says the probability, P of A, of any event A satisfies the following. P of A is between 0 and 1. And you notice it's greater than or equal to because the probability of any event is between 0 and 1. That's it. That's all it's telling you. For any event, you can't have a negative probability and you can't have a probability greater than 1. That's what this says. And if you're ever wondering how to read this in math, just look at how it physically sits. Since this is in between 0 and 1, that's how you read it. P of A is between 0 and 1. You could also say P is greater than or equal to 0 or less than or equal to 1. So I'll give you a second to write this down. Probability rule 2, it says the sum of the P sub i's is equal to 1. And I told you what this means right here. Total probability is 1. That's what it means. Total probability is 1. And we've talked about this before. We've talked about it with proportions. We talked about it in the normal distribution. We understand that the total probability has to be 1. Because all of our events have to add up to a total of 100%. So make sure you write this down, or write this down total probability as 1, or just some way so you understand probability rule number 3. Or number 2, rather. So probability rule number 3. It says the complement of any event A is the event that A does not occur. It is written as A complement. The complement rule states that A complement is equal to 1 minus P of A. So let's think about this for a second. So P of A is the probability that any event occurs. So if for example, if P of A is 0.2, so if P of A is 0.2, the probability that does not occur must be 80%. And if you read this rule and you do a little bit of mathy stuff, you'll also find this to be true. The probability of A complement plus the probability of A is equal to 1. To put it in simple terms, either an event do happen or it don't. That's it. So I'll give you a second to write this down, and then we'll go on to probability rule number 4. And that's all we'll have for right now. There's more probability rules, but all we're going to do is cover 1, 2, 3, and 4 in this video. Probability rule number 4. If two events, A and B, have no outcomes in common, they are disjoint or mutually exclusive. They can never occur simultaneously. And here are the rules. If A and B are disjoint, so if P of A or B is equal to the summation of the two. So some events that could be disjoint would be the probability of a team scoring 1 point in soccer or no points. Those two events are disjoint. Either you score a point or you don't. This is the addition rule. You're going to need this rule. It's pretty important. We're going to make it more general later on. And you're going to need this to go with it. If A and B are disjoint. And I'll show you what it looks like in a little bit different way in a second. So here's probability rule 4 written in a way you're not used to seeing. But this says if A and B have nothing in common, they don't intersect at all, or their intersection is a null set, or they're disjoint, the probability of A union B, and we found out this is OR, is equal to the probability of A plus the probability of B. And this is just a different way of stating it. So I'll give you a second to write this down so that you know how to use unions and intersections. The way I remember these symbols is, see this union here? It kind of looks like a U for a union. That's, in my opinion, the easiest way to remember it. We only have a few more things to go over, and then we'll wrap it up. So let's go on. Probabilities in finite space. Finite means you can count it. That's all finite means. Finite means countable. It's the opposite of infinite. So here's what you do. You assign a probability to each outcome, and we know it has to be between 0 and 1, and everything has to add up to be 1. That's probabilities 1 and 2 together. The probability of any event is a sum of the probabilities of the outcome making up the event. So in other words, this is just extending the rule 4 that we just learned about. So in other words, the probability of A plus the probability of B plus the probability of C. And if all these together, the probability of A is 0.2 plus 0.3 plus 0.4. We're still missing something, so we're going to need another probability. We'll call that probability a D. That's right, 5, 6, 7, 8, 9, 10. Okay. Oops. And that's all it's telling you. So the probability of any of these events occurring is 0.1. And if you want to know what the probability of A or B is, you just add those two, A or C, A or D, A, B, or D. You just add them up. This is just an extension of that rule number 4. So I'll give you a second to write this down. And this is just how to calculate probability in finite space. Another way of looking, like, you want to know what the probability of any event is, take the number of desired outcomes over the total possible number of outcomes. And I think I have an example here. If not, ask me in class and we'll go over a little bit more, because this is where it's a little shaky for students. So let's look at my example. So I'm going to go on. Okay, you know, actually, I'm going to skip this slide, and I apologize for doing that to you, but we'll just keep it here, and I'll give you an example of this. Let's say there are 50 ways to win. There are 150 total outcomes. Probability then is 50 over 150, or 1 over 3. And you can express either as a fraction or as a decimal. It doesn't matter. If it's a decimal, express it to 2 decimal places. That's enough accuracy. So this should have been our introduction to sample space and everything else, and we should be good to go. And I apologize for showing you that one slide and not talking about it, but I think that's something we can discuss in class. Okay, that's it.